If the idea of rescaling things to unit vectors made sense to you in the previous standard, then this is really just an extension of that. In fact, I'd say it's about 99% the same. Okay, so for example, if I wanted to turn this into a length of 1, all I would do is take that x, that y, okay, find the magnitude of that, and divide both the x and y components by that. The only difference between this section versus the previous section is literally, maybe I don't want the length to be 1. I can make the length as whatever I want. So whatever the desired length you want is, that's your numerator. And it should make sense. So once again, if I wanted to turn this into a length of 1 from the previous section, all I have to do is magnitude that. That's 36 plus 1, 37. So it would be 1 over 37. And I would have a length of 1. But if I want my length to be anything other than 1, for example, in this case, I want it to be 2, literally all I have to do is double that, and there's my answer. Okay. So again, 99% the same thing, except we're just changing our numerator. Instead of 1, it's going to be whatever desired length you want. So it doesn't have to be a unit, okay? So again, same thing. I'm going to take my original vector, okay? If I wanted to shrink this into a unit vector, then I would magnitude that. What is that? That's going to be 73, so square root of 73. So it would be 1 over 73. So if I wanted a unit vector, that would be a 1, because that's the scalar multiple. But now I don't want it to be 1, I want it to be 5. So literally all I have to do is change that to 5. So 99% the same thing as unit vectors.